Hello everybody, welcome to this new episode. On today's episode we are going to set up a network with 3 routers and 3 nodes, 3 workstations connected to every one of those routers. So the purpose of this exercise is to configure static routing and provide alternative paths for routers to reach its destinations, or better say for networks to reach destinations. So in the event of one failure link, in the event of, let's say, one physical connection being deactivated, we will always find a path to the other networks via alternative gateways. So let's get started. I will just start from scratch. The IP subnetting right here is not really it's not necessary what we're going to use. We're going to do it from scratch. Maybe you can follow along. It's let's get started. So first of all we bring 3 routers onto the board. I will name them later as up, left, up, right, and down. So we need also to connect 3 computers to represent the networks, 3 networks right here, and we will need a laptop computer to connect directly via a console serial connection from our RS-32 onto the console of first router. We need to set up also, link all those routers together. We're going to choose this one to be connected on the gigabit Ethernet 0. From here we're going to connect on the 1, let's say, and this last one will be connected on interface 2. All right, so now we make sure that all devices are connected. All devices will be connected in this fashion, and finally this last PC over here. Good. So the next thing we need to do is we need a scheme, an addressing scheme. We need to provide, okay, let's consider that we have 3, between each router, we have 1 network. So this is 1 network between, so we have 1, 2, 3 networks between all the routers, and for each computer, which represents another network, we have then another network. Okay, so let's get started. Let's define some IP addressing for this network. Let's try to get the 10.0.0.128 with a mask of 24. For this network we can define 200.0.0.128/24. okay, it's actually /25, since this is a 25-bit mask. And for the last one, it's not the last one, but at least on the upper side, we can take a 192.168.0.128. I'm choosing old 25 masks just to keep it simple, although in fact I should be using at this level between the routers, I should be using at least 30 masks, but let's see, I might just change it along the way. Just so we have that one, and for this we can choose another random 0.0.0.128/25. we need here another network. Let's take the 172.168.0.128/25, and the last network, which will be here, We can consider IP number, something that I didn't have already. Can we take this IP? Let's see. We'll see how it works. All right, so now we can get started with configuring, with the configuration of these routers. First router, we are going to set up a configuration. Say no, enable conft hostname. We're gonna call this guy upleft. We call it just simply upleft, and we need to we can enable SSH. Why not? Although we're going to focus on the networking part, so let's leave the router with a minimal configuration to get just focused on the networking part and the addressing part. So the first interface, the upper interface over here is, let's see if I can highlight which interfaces are, oops. So this is the 0. I had seen somewhere. Okay, this is the interface 0, which means that I'm going to assign an IP to the interface 0. So interface gigabit internet 0/0, it will have an IP address 200.0.0.129. Let's consider that these, if I use 250, if I use the 250, okay, let's just to keep it simple, I'm going to assign the 192, the first IP address available of that network, which is the 129 with a mask of 255.255.255.128, which is 25 bits mask. So that IP is set up. Now I need to assign to the next interface, the one going down here, and this interface is the 01. For interface 01, I'm going to just say interface gigabit 01, and the IP address for this interface is going to be 100.0.0.129. again, the same mask, 25.128 is a 25-bit mask. So that is correctly assigned. And for the third interface, which will be, we have already 01, so the last interface over here, the one pointing to that computer, to that network, should be the 02, right? So we go interface gigabit internet 02, IP address will be 10.0.0.129 again, and the mask, which will be 255.255.255.128. So this is all set for this first router, the upleft router. So let's now configure the node, the desktop right here. I'm going to connect to 10.0.0.129. Oh, sorry. This will be the next IP available for this computer, and we're going to set up this mask 5128, and this goes for 0.0.129. So that is my default gateway. So now we can try to just oh, wait a minute, I think I forgot bringing up the interfaces. Actually, I configured the IP addresses, but I didn't bring up the interfaces. So now this, at least this interface is up. I will try to bring up the other interfaces. That was one node shut down, to 2 and 0, not shut down. So interfaces are up and running. We could actually try to ping this computer, the node we just configured. Let's go ping 10.0.0.130, right? That should be the left over there, and it says success. So it's okay. Now let's move on to the next router. So I'm gonna take oops, how can I, something is not working here. Why can I not disconnect this cable? Okay, let's move on to this one up here, and now we're going to configure this router in the same manner as I did with the other one. I will say no. Again, I'm not focusing on this exercise on the security aspects and setting up the router with the proper configuration. I will just focusing on the static IP addressing for this exercise, just to keep it simple and short. So I will configure the interface. If I'm not mistaken, this interface was the 0.0, which was the first one on LA. So I will go into the interface, gigabit interface 00, and I will assign the IP address here of the IP address will be 200.0.0.129 is taken, so we take the 30 with the 255.255.255.128. Not shut down this interface. Now we have the first interface is up, so that if I ping, let's say 10.0.0.130, oops, let's see if I ping this interface. I'm trying to ping the workstation at the other side of the network, and subset rate 0. Let's see. So yeah, I cannot find that network apparently. Okay, that's no problem, because we need to complete the routing stuff. So we're going to configure the other interface, the one pointing to this end, which is on the .1 interface. For that one, we're going to say interface gigabit 0/1 IP address 192.168.0.129 with a mask of 255.255.255.128, not shut down. Then we need the interface 2, right? We have the 1, the 0, now we need to enter the interface 2 and configure this IP address here, which will be IP address 168.0.0.129 with a net mask of 255.255.255.128, not shut down. And now that we are here, let's just set up the IP for this computer, for this network station, for this computer. So let's go and say 192.168.0.130, because 29 was taken for the default gateway. And here we're going to just let's see if I can copy and paste to make it simple. 29. So it goes on to the 129 from this interface. Very good. So now we just need to configure this last router right here, we're going to do the exact same thing. Which will be saying enable. I think I didn't give it a name, right? The other one I think I didn't give it a name. So conf host name, I'm gonna call this router down, and I'm going to configure the interface going to the right hand side, which is the interface 02. So the interface 02 says interface gigabit 0/2, and the IP address for this interface is going to be 168.0.0.130, since the other one was taken, and 255.255.255.128, which is the mask, not shut down. And we see how the interface came up. For this part down here, we have the interface 00. Let's give this interface an IP address, and that'll be the IP address 172.168.0.129 with a mask 55.555.128, not shut down. So this one is configured. Now we have only one left, which is the interface. We have the 00, we have the 02, now we have the 01, right? And that should be IP address 100.0.0.129 with a mask 255.255.128, not shut down. So now our interfaces are up and running. Two of our computers are configured to use the network. Now we need a third computer down here to have its TCP/IP configuration in place. This will be the 172.168.0.130 because we already took the 29. The mask will be 255.128, and the default gateway for this computer will be the 129 over here. So now our network is set up, but so far we cannot do much routing than probably pinging the router and probably pinging the interface on the other router. Let's see what we can do with this setup so far. So I'm right now on the PC2, the one here on the down side. If I ping my 172.168.0.129, which is my default gateway, I have a response. What if I try to ping one of those interfaces in this network over here? What will happen? Let's see. So we go 100.0.0.129 is one of these interfaces. I'm not sure whether it is the one at the up left or the one down, but we are going to ping both. For the 130 is giving me a request timeout, because so far we can only I can assume that the 129 probably was my interface right here. So we can check out that. We can connect here and see what is the state of my interfaces. So I say show running config. We'll see that the interface 00 is the 129. I mean the 172. On the 100 we have the 129, which is my directly connected interface, right? So this interface I can ping from my workstation here because it is a directly connected interface, right? The 29 response is the one directly connected, and this one over here should also respond the 168 directly connected interface 168.0.0.129. Let's see, that is not directly connected since it's not responding, but the 130 is directly connected on this side. So that's as much as I can do with the current state of situation. So now we need to start adding routes. So what we need to do is we need to tell this router over here, the router down, that whenever an IP of this network is requested, we will forward the request via this link. And the same will happen when we route or an IP is requested belonging to this range. We're going to send via this exit. The same we have to tell all the routers. So this router we need to tell the same. Whenever this network is requested, send them via this network. And whenever this one is requested, we're gonna go via this line over here. So, and not only that, we're gonna tell them, okay, this is gonna be the primary path to reach this destination, but we're going to define a secondary path, an alternative route, and that will be going above this. So for that we need the administrative distance metric, and so in the end every router should have 4 routes in its routing table. So one for reaching this, one for reaching this one here, and 2 alternatives for each one. So this network will be reached via this link, that will be the preferred path, but alternatively we also want to send via this link in the event that this interface is down. So let's get started. So the first thing that I'm going to do here is connect again via my terminal, and I need to identify first of all okay, this network. So I will say conf d IP route. So we will route to the network 192.168.0.128. We're gonna route to this network on the mask 255.255.128, and we need to tell which IP we are going to send it to. So it cannot be an IP on my router, it needs to be the IP on this router over here. So let's see if I can figure out which IP that is. That should be of the 168 family, and we see on the 168 that is the Giga Ethernet 0/2. So that's going to go on the 129. So let's go back to our terminal and choose the IP 168.0.0.129. So that's how the route will look like. And we need also to give an alternative to this route with a metric 2, and the alternative will go on the left hand side. So this will be the next hop. Alternative next hop will be this router right here, and on the family of the 100 we have here the IP 129. So we can then tell this guy here that this can go by the 100.0.0.129 alternatively. So I'm giving it 2 is the metric, so it's the second priority. That's good for this one. Something is So it's telling me that this IP address is in my own router, which is kind of strange, but I'm going to confirm that. So show routing, and let's see on the 100 family, where is this? We have this 100 family, and yeah, it is in my own interface, but I also seeing that the other router has the same IP configured, if I'm not mistaken, because I can see that 129 here, and I can also see that 129 here. So I will change this IP of this interface, which is the gigabit 01. So conf t, and then let's interface gigabit 0.1, right? Yeah, and then IP address 100.0.0.130 with a mask 255.255.255.128. So now I can go back to my okay, that's the one. So I configure it like 30, right? So I will just assign it to the, I'm sorry, mine is 30. So the next router, the next hop is 129. Now I think I need to also bring up that interface. If I didn't do interface gigabit 0.1, maybe it's already up. Anyways, so now it is done. I have, if I check now my routes, show running, let's check out which routes we have. Show running configuration, IP route. We have two routes, right? Two routes to reach this network on the right hand side. Now we're going to do exactly the same for the other network, the network 10.0.0.128. We need to reach it via primarily IP routes network 10.0.0.128 with a mask of 255.255.255.128. Should we reach through this IP address 100.0.0.129, no priority, which means that's the default way or gateway, and the same network should be reached also via the 168.0.0.129 as an alternative, so we give it a 2. So now we can check out all our routes, show running config and IP routes, and we have 4 routes, 2 alternatives and one primary. So now we can connect to the next router, let's say this one here. We have to do exactly the same. I'm gonna connect here and do exactly the same operation. I didn't give it a name to this router, so conf t host name, we call this upright, so that we know exactly which router we are talking about, and we're going to configure the exact same IP schema here, and that goes as follows. For the interface pointing towards the network down here, this is the interface 0/2. So for the 0/2, we're going to interface gigabit 0/2, and we give it an IP address. I mean, I already given. I'm a little bit confused. I'm going to do, we already have IP addresses in place, so I just want to check out my IP addressing scheme first. show running config. Just let's check. Okay, so the interface 0 to 0 is the one on the upper end, and the 192 goes, the 1 goes to the computer and the 2 goes to the other network. So I'm going to copy this, probably can be helpful. Get it? Yeah. So let's get started. So the first thing that we're going to do is set up a route that will allow us to reach network 10.0, right? So the way we do that is, we say conf t IP route to networks 10.0.0.128 with the mask 255.255.255.128. We are going to forward via the 231 IP address. Why 31? Because, 129. Because the IP 130 is supposed to be the one directly connected to our router, and the first address 129 should be the one attached to this other router. So that's how we do it. That's the primarily route to find that network, and we need a secondary, and the secondary will go via the 168 link, and the 168 link goes as follows. That should be the 130 in this case, right? And this will have a priority 2. That's the administrative distance. So that's all for this route. Now we're going to configure, set up a route to find this network, the 172 network. So the way we do that is simply by saying IP routes, IP route the 172.168.0.128 with the mask 255.255.255.128, and this has to be reached via the 168 network, which is again this network, but then 30. So we're talking about now this is the first way to reach this network. Okay, so the second way to reach this network is via sending to the 200, right? So we're going to also find the network 172.168.0.128 with this mask, and that can be also be found via this link over here, but that will be the secondary, right? So how many routes we have? Show running config IP route. So we already have 4, 2 alternatives and 2 primary. So that's all for this section over here. Now we can move on to configure the other router, the one here, the upper left. And what we do here is simply exactly the same as we did for the other 2. The up left, enable show running configuration. Let's check out how the interfaces are now configured. Let's copy this information into my notepad right here so we know exactly what we're doing, and let's start configuring this. We're going to configure terminal, And the first thing that we're going to do is we're going to provide a route to reach the 192.168.0.128 network. So what we do is we say IP route 192.168.0.128 with a mask 255.255.255, 128 25-bit mask. We're going to find this going on the 200 IP address, but not ours. We're going to find that one going on to the 30, right? That's going to be the primary way to reach that network, and the secondary way to reach that network will be via the 100 network, which is here 130, right? That is the 130 goes over here, 100.0.0.130, and this is going to be a secondary way to reach that network. Oh, something inconsistent address and mask. Something is not okay here. It's telling me that the mask is inconsistent because we have 2, 3, 4. What is wrong here? We have IP routes. Let's write it from scratch. See what is wrong here. IP route. So we need a route to the 172. Oh no, sorry, I'm finding a route to 192.168.0.128 with a mask 255.255.255, 128, and we're going to find that via this right here, the 100.0.0.130, and that will be the secondary way to approach that. So it's telling me that it's an invalid input. Yeah, that's invalid because I forgot to provide or to mention routes. So that's good. That's the secondary. Let's just double check how a running config is doing. Running config IIP route, and we have so far only 2 routes on the end, and both are prepared to reach the network 192.168.0.128. Now the last one will be to configure alternative routes to reach the 172 network, which will be provided by saying IP routes 172.168.0.129.28 with a mask 255.255.255.128. That primarily gateway will be on the family of the 100, which is the 100.0.0.130, and we're going to do the same for the alternative path. The alternative will be actually the IP on the upper end, the family of the 200, which is 200.0.0.130, and this is with the administrative distance of 2. So if I check again the whole routing table, we can see IP route that we have 4 paths. So now we can test what will happen if we ping from this device any computer in this network over here in the 10.1.0.128 network. So we try like 0.0.129. Might take a while at first before the routing table populates, and after a couple of seconds it starts responding. So the same for the default gateway, which should be the 130. That works. Now we ping this network over here, located on the 192.168.0.129. The same behavior should occur a couple of seconds, request timeout, and then it starts replying. Notice that we have here a 2:54 time to leave, which starts at 2:55, and we will see how that time to leave increases when we disconnect one of the interfaces. So that was from this end, and we can also test it from here to work the same. We ping the 10.0.0.129. Again, it delays for a couple of seconds, request timeout, and then it starts replying properly. So now the next thing will be to disable one interface and see that everything's continue working, and see that there's definitely redundancy in the connections and in the routing table. So what I'm going to do right now is try to disable one of the interfaces, show running config to see which interfaces are attached to which IP. So the interface 00 is the one on the upper end here. I'm going to disable that interface temporarily. Conf t interface gigabit 0/0 shut down. So now the interface is disabled, and we are going to try to reach this network, the 192.168.0.128, from this segment, from the 10.0.0.128. And we're going to examine the time to leave response of the ICMP message, 192.168.0.129. Should that be? So we see a time to leave is less. In this case, it's not 2:54 but 2:53, because we are passing, we are traversing two routers to reach the destination, and by each router the time to leave will decrease in a factor of 1. So that is the proof that there's redundancy in this connection, and it should work for the others as well. So I wanted to connect to the terminal. From the terminal, now I can just bring down another interface. In this case, I will bring down the interface interface 1, this one. So I say interface gigabit 0/1 shut. Oh, actually I was supposed to bring up the other interface, because now we have two interfaces down, and that won't work, of course. So let's bring back that interface up so that we can test the other side. That was the 00 interface, not shut down. Now the interface is up, and we have an interface down. So we need to find, see if we can ping from the PC2 on this network 172.168.0.128. See if we can ping a host located in this segment of the network. So now I'm going to ping the 10.0.0.129. Might take a while until it goes all across. We should get a 2:53 time to leave, because we are going across these two alternative paths since this line is down. If we bring the line up again, we bring this line up, this interface, that is the interface 01, I guess. Let's see, not shut down, yep. And we ping again from this workstation. It should choose the fastest path to its destination, which is just one hop. It might take now a while because the routing table was reconfigured when the link was failing, and now we see how it replies with just the time to leave of 2:54, meaning that it's choosing the shortest path to the destination. So that is basically how it works. The static IP routing versus dynamic routing. This is not advisable for production. It's more for the sake of the exercise and understanding how static IP routing works. Yeah, that's all for the moment. Thanks for watching.